Okay, so we're going to talk about chords today. A chord is a segment whose endpoints are on the circle. So we've got chord PQ, whose endpoints P and Q are on our circle. And we're also going to be naming our circle based on that center. So it's circle O for our first example. So now we're going to look at some theorems about our chords. First one relates our central angle in our chords. Central angle in our arcs, sorry. So if we have angle AOB and we know that it's congruent to angle COD, so we've got AOB and angle COD and we know that they're congruent. We then know that the arcs that those angles cut off, like arc AB and arc CD, those are going to be congruent. So this arc, which is cut off by the same angle with the same measure as this arc, are going to then be congruent. And the converse is also true. If we know that the arcs AB and CD are congruent, then we know that the central angles AOB and O is just, this is from a little while ago, but we're going AOB. That's going to be congruent to angle COD. And on we go to the next theorem, also relating central angle now to our chords. If we know that our central angles AOB, there's A there, is congruent to angle COD, other central angle, then we know that the chords, those lines, those segments that have their endpoints on the circle, AB, so chord AB is congruent to chord CD because they kind of cut off that same little area. So if we go angles are congruent, then the chord, so the segment now, not the little arc, those are going to be congruent. And the converse is also true. If we know that the chords are congruent, then we know that the central angles are congruent. All right. So those first two relate central angles to chords and arcs. Next, we're going to talk about chords and arcs together. So if we know that we have congruent chords, so if AB, the chord, so this guy, is congruent to CD, chord, then we can say that the arcs that they basically cut off, arc AB is going to be congruent to arc CD. So the little arc that those two chords cut off are going to be congruent. And the converse again is true. If the arcs are congruent, Oh, I should draw an arc. Then we know the chords are congruent. So we're just writing the theorem and its converse. So we can go in either direction. Depends on what you're given. And then the last theorem if we have chords that are equidistant, so our chords A, B, and C, D are equidistant, so the same distance away from our center, then we know that they're congruent. So if from the center out, so OE, that length is the same as from the center out OF, then our chords AB are congruent. A, B, and C, D are congruent. So this the same distance away. So chords equidistant from the center are going to be congruent. And our two examples relate to that theorem. So what's the length of RS in circle O? So RS is a chord here. And is it equidistant? So is it the same distance away from our center? We can check that it is. It's 9 units away, and that one's 9 units away. So we need to figure out the length of PR so that we'll know what PQ is. So PR is 12.5 twice, because it looks like we've got 12.5 here, 12.5 here. So RS is 25 units long, because it's twice that little segment down here. Then find the value of x. So finding the value of x, we know that these are the same length, and then now we have to go back to the theorem. So if they're equidistant, then our chords are the same length. But we now know that the chords are the same length. So that actually means, is the converse true? And yes. So if I know that this guy is 16 and I know that my chords are congruent, then I know that they are the same distance away. So we're going to get 16 again. And that's it for chords for part 1.